All right, well, we'll work out these problems real fast from the free fall stuff. Again, main thing to remember is something free falling is that we have an acceleration due to gravity, and that acceleration is going to be approximately 9.8. And if we're thinking of it in a downward direction, it's going to be a negative 9.8. So if we do question number one, let's list the things that we know. We're looking for the distance. I don't know it. I know a time, and that's all that's in the problem, although there's some hidden things in the problem. If it's being dropped, it has an initial velocity of 0. And if it's being dropped, then the acceleration is negative 9.8 meters per second squared. Since we're looking for D, you can look on your formula sheet. Got mine here in front of me. Let's check. So our formula for D is the one that says D equals VI T plus 1/2 AT squared is the one that we can use for this one. Because VI is 0, then we don't need to worry about that part because it's going to cancel and turn into a 0. So I've got 1/2 AT squared. We just need to plug in our numbers. So A is 9.8 and T is 7, and I need to square it. So be careful on your calculator that you put it in that way. So I'm going to get 1/2 times 9.8 times 7 squared, and you get all that in. I don't have a calculator in front of me. Let me go grab one. Fantastic high quality video production here, but we're trying to get an answer. That's all that matters. So 1/2 times 9.8 times 7 times 7, and we get about 240. And again, this would be a distance, so we're looking for meters. It would also be in a downward direction, so if it asks for actually displacement, that would be negative 240 meters, just to indicate that it would be going down. All right, moving on. Stop and rewind if you need to. All right, number 2 is asking about how fast something will happen if it's falling. So again, let's look at what we got. We got a time, which is 5. We're looking for a how fast, so we're looking for a final velocity. If it's dropped, its initial velocity is 0, and falling with acceleration, so negative 9.8 meters per second squared. With this one, with our final velocity, we can simply use the formula, 5th one, I believe, on your formula sheet, where it says VF equals VI plus AT, because we've got the A, we've got the T, we know VI is 0. Since VI is 0, we can ignore it. VF equals AT. Plug in your A, which is negative 9.8. Plug in your T, which is 5, and we multiply those together. That's going to give us an answer. So 9.8 times 5 is going to be negative 49. And again, if you wanted a unit, we got to think negative 49 what? How fast? So that's going to be a speed. Since our acceleration was in meters, this would have to be in meters as well. So negative 49 meters per second. If we were looking for a direction, or if it was just the speed, it would be 49 meters per second. Moving on. Stop, rewind, watch it again if you need to. Number 3, we've got a little bit of a twist here. How long would it take to hit the ground if it was thrown up at 50 meters squared? So we're looking for a time. Now this one, the initial velocity and final velocity, neither one of them are actually 0. So if it was thrown up, if it left my hand at 50 meters per second, then the velocity when it comes back down would be the same, but in the opposite direction. So it would be negative 50 meters per second squared. So in theory, you throw an object up, whatever speed it leaves your hand is the same speed it should be at when it hits back. And then our acceleration is negative 9.8 meters per second squared. Just like in question number 1, we're trying to solve, let's see, in this case, we're trying to solve for time. I know let's see, figure out which formula we've got to use. So I've got a VI, I've got a VF, I've got an A, and I've got a T. So we're going to use the same formula that we just used. But in this case, we're solving for the T, so we have to do a little rearranging. So in this case, to get T by itself, right, first thing I need to do is I need to get rid of this VI by subtracting it from both sides. So when I subtract it on the left side, I'm going to get VI minus VF. That doesn't look very good. I can erase that, make it look a little better. I'll do it over here, so I've got more space. So here's the formula again. And again, I'm trying to get time by itself. So I need to subtract VI off of both sides. That's going to cancel that out on the right-hand side, but it doesn't cancel out on the left-hand side. And then again, trying to get T by itself, A times T, I need to divide out the A. So the A's are going to cancel over here, and I'm left with VF minus VI over A. So now I just plug my numbers in. VF was negative 50, VI was 50, and A is negative 9.8. So negative 50 minus 50 is going to be negative 100 divided by negative 9.8. That's going to be approximately 10. So again, I get 100 divided by 9.8. Those will both be negative. But when you put in the calculator, they're going to give us a positive answer because, again, it's time. So when we have time, time always needs to be positive, and it comes out to about 10.2 seconds for that. So we got an object going up, coming back down. All right, and then the last one, again, stop, rewind, watch it again if you need to. Number 4, how far does the ball fall for 3 seconds? So again, we'll list out what we've got. We're trying to find distance. We've got a time, which is 3. We've got an initial velocity of 0 because it's falling, and we've got an acceleration of 9.8 because we're going to assume it's on Earth. Being lazy and not writing the units. But again, we're trying to get a distance on this one. Distance is VIT. This is the 4th formula on your formula sheet. Again, because VI is 0, don't need that. So it leaves us with 1/2 AT squared. So we can just plug things in. So I got a 1/2. A is 9.8. And T is 3. T squared is 3 squared. Put that in our calculator. So 1/2 or 0.5 times 9.8 times 3 squared. And that's going to give us 44.1. 44.1 what is how far, since we used meters per second squared as our acceleration, this must be in meters to be consistent with the distance that is mentioned in the acceleration. There you go. There's the basics of working these problems out. Watch it again if you need to. Ask questions. If that doesn't work.